This is Biddeford High School Graduation Standard A1.1 Solving Equations. So let's take a look at this example right here. We have x plus 6 equals 10. So this really shouldn't mean anything to you right now. It's just the example that we'll keep coming back to learn how to solve single variable equations with one operation. So look at the situation above. In this unit we will be solving for unknowns, also called variables. For this problem, x is the variable. Okay, so that means we just don't know what this value is. Okay, but it does have a number value. Okay, so let's do some vocab. A variable is a symbol used to represent a quantity that can change. Okay, so a quantity is just an amount or a number. Okay, so variables are most often written as a lowercase letter. So if we look at this example above, x plus 6 equals 10, there's a reason this x is lowercase. It is not uppercase, okay? Because variables are most often written as a lowercase letter. Okay? I'm going to move on. Pause the video if you need more time. So let's look at some examples of variables. So, as we said, just lowercase letters. So we could use x, y, z, a, b, c, etc. Okay. There are a couple letters that we will not use or you will not commonly see used as a variable because they mean something else in the world of mathematics. A good example of that is the lowercase letter e. Okay, so let's look at the word equation. Sure, we've heard of it before. So an equation is a mathematical statement that shows the values of two expressions are equal. Okay, so in the problem at the top of the page, the equation is x plus 6 equals 10. So this equal means this expression, x plus 6, and 10 have the same value. Okay, so we'll come back to that a little later. A coefficient is a number that is multiplied by a variable. Okay, and we'll need to know this word a lot throughout this standard. Okay, pause the video if you need more time. Okay, so back to coefficient. If the variable appears to not be multiplied by anything, the coefficient is 1, because 1 multiplied by any number is that number. Okay, so that should be nothing new. So if we were to have 1 times a, we could just rewrite it as a. If we have 4 times 1, we know that it equals 4. Similarly, if we have 1,000 times 1, it equals 1,000. Okay? There are countless examples you could use to show this. So, in these spaces below, write what the coefficients are on the line. So here we have 4 times y. Okay? So the coefficient is 4. We have x minus 7 equals 3. Well, if we look up here, we look at our variable. Okay? Well, it's easy to tell that this first one was multiplied by a 4. This one doesn't appear to be multiplied by anything. Because of that, our coefficient is 1. Now this example over here, we have 2 equals 8 minus 6r. So here we have our variable, and it is being multiplied by a negative 6. So let's look at the word solution. Solution is a value that we can put in place of a variable. Solution is also referred to as the answer. Okay? So even outside of math, if we were looking at a real world problem, if we were looking to a solution to someone's problem, we're looking how to solve it. Okay? The answer to their problem. Okay? Pause the video if you need more time. So back to our original problem. We have our equation x plus 6 equals 10, with our variable being a lowercase x with a coefficient of 1. So what is the solution of this equation? Okay, so this is asking what number plus 6 equals 10? Okay, well that's not too difficult. Even if we count on our hands or our fingers, we put up 6 fingers. How many more fingers do we need to get to 10? Well, assuming you have 10 fingers, you only need 4 more fingers. So, our solution is x equals 4. Okay, so this is where we start the standards portion. Okay, so let me get a different pen here. Okay, so this is level 1 of A1.1. Okay, so after going over this portion of the standard with a little bit of practice, you should be able to solve equations in one variable using a single operation. Okay, So just like the problem we had, x plus 6 equals 10, that would require one operation, which we will get to shortly. So, in the problem above, think about the wording in your head as you tried to solve it. In fact, we wrote it down actually. It probably was something along the lines of x plus 6 equals 10, or some number plus 6 is 10. Using the... Sorry about that. Using the guess and check method, it isn't hard to tell that x equals 4. Okay? Well, let's take a look at this problem right here. This will be a level 2 problem. X divided by 3 plus 4 equals 12. Is the guess and check method the best strategy possible to find our solution for x? When problems get too complicated and time-consuming to use the guess and check method, we have other strategies we can use to solve for our variable. Again, let's look at our original problem, x plus 6 equals 10. So our goal in solving equations, okay, it doesn't matter which level of the standard we're dealing with, is to isolate the variable. Okay, and for those of you that do not know the definition of isolate, that means to get by itself. So we are trying to get our variable by itself. So how can we do this? Okay, if the 6 weren't there, we would actually be all set. We would have x by itself and we would have our solution. So to do this, we will subtract the 6 from both sides. Okay, and this is called the subtraction property of equality. Okay, this tells us that whenever we have a number being added to our variable, we can get rid of it by subtracting whatever number is being added to the variable from both sides. Great. Pause the video if you need more time. So let's take a look at a few examples here where we will need to use the subtraction property of equality. So our first equation in the upper left hand corner is c plus 5 equals 12. So this is how I'm going to solve these. I'm going to make a little t-chart. So I'll make a horizontal line down bottom here and a vertical line right underneath my equal sign. So using the subtraction property, I have a number being added to my variable. So, as we just said, I'm going to subtract that number. So minus 5 here, minus 5 on this side. Okay? So 5 minus 5 is 0, which leaves me with a c on this side. My equal sign drops down, and 12 minus 5 is 7. Okay, so my solution is C equals 7. Okay, let's go to this one over here. Same thing, make my t-chart. Subtract 2 on this side because it is being added to my variable. Subtract 2 on this side. So 2 minus 2 is 0, so those cancel. I'm left with W equals 7 minus 2, which is 5. This example down here, make my t. So I'll subtract 13 from this side and subtract 13 on this side. So 13 minus 13, they cancel. I'm left with a t on this side equals 20 minus 13, which is also 7. Right. In our last example here, one more t-chart. Subtract 6 on this side. 6 minus 6 is 0. Subtract 6 on this side. So I'm left with a p equals 2 minus 6, which if we look at a number line is negative 4. Awesome, let's move on. Okay, so similarly to the subtraction property of equality, we have the addition property. Okay, so this tells us that whenever we have a number being subtracted from our variable, again, we can get rid of it by adding whatever number is being subtracted from the variable to both sides. Okay, so I think the best way to learn these, let's do some more examples. So again, I have my t-chart. That won't change. So 3 is being subtracted from my variable y. So using the addition property, I'm going to add 3 to both sides. So negative 3 plus 3, that cancels, so I'm left with a y equals 2 plus 3, which is 5. On this side, t-chart, 10 is being subtracted this time from my variable x, so I will add 10 to both sides. So negative 10 plus 10, they cancel. I'm left with x equals 16 plus 10, which happens to be 26. Okay, moving on. Okay, again, t-chart under my equal sign. So 4 is being subtracted from my variable. So I will add 4 to both sides. So negative 4 plus 4 is 0. So I'm left with n equals 9 plus 4, which is 13. And this last example, a minus 1 equals negative 8. So 1 is being subtracted, so I will add 1. They will cancel. So I'm left with a equals negative 8 plus 1, which is negative 7. And for those of you that may be struggling with the negative numbers, let's take a look down here. So let's say we're at negative 8 right here. Okay, right here on the number line. So that would mean this is negative 7, and over here is negative 9. Okay? So if we were to go this way to the right, we would get closer to 0. If we were to go to the left this way, we would get closer to negative infinity, the really large negative numbers. So when we're adding, we are going this way. When we are subtracting, we are going this way. So negative 8 plus 1 means I will go this way on the number line to negative 7. Okay? So we also have the division property. Of equality. Okay? So whenever our variable is being multiplied by what we're going to see more often than not is a whole number, we can isolate our variable by dividing by that whole number. So we have multiplication. So how do we undo multiplication? We use division. So let me switch up my color here. Okay. Still make my t. So this means 2 times x. 2 is the coefficient. So in order to get rid of it, I will divide by 2 on both sides. So 2's cancel. I'm left with x equals 6 divided by 2, which is 3. Okay. Again, let's look over here. T-chart. I have 7 equals 3 times z. So I need to get rid of this 3 here. So I'll divide by 3 on both sides. 3's cancel. I'm left with z equals 7 divided by 3. And I know first instinct for a lot of students, they see an improper fraction like this and they think, wait a minute, we need to change that to either a decimal or a whole number. In this class, these types of fractions, improper fractions, will be our friend. So you are okay to leave it just like this. Even though it might look wrong originally, you are okay to leave it as 7 over 3. Okay, move to this next example. Okay, negative 10 times r. So I'm going to divide by negative 10, because if we were to divide just by 10, negative 10 divided by 10 is negative 1, okay? Where we want our coefficient to be 1. So divide by negative 10 on both sides. So r equals 50 divided by negative 10, which is negative 5. Okay, last example here. Negative 3 times d equals 18. So I'll divide by negative 3. On both sides, those negative 3's will cancel. So I'm left with negative 6 on this side equals d. Okay. And the last situation we will deal with in this standard is when our variable is being, or this level of the standard, is when our variable is being divided by a whole number or multiplied by a fraction. Okay? Because that really means the same thing. Okay? So to solve these problems, we will use the multiplication property of equality. Great. So again, let's look at some examples. So right here we have v divided by 2 equals 5. So you could look at this as a fraction or our variable being divided by a whole number. Same thing. Okay? So as I said here, I will multiply. So to get rid of this 2, I need to multiply by 2 because 2 divided by 2 is 1. So whatever I do on this side, I have to do on this side. Multiply by 2. These 2's cancel. So I'm left with v equals 5 times 2, which we know is 10. Okay, let's look at this one. 1/3 times g equals 4. So to get rid of this 1/3, I'll multiply by 3. Those will cancel. And I'll multiply by 3 over here. So I'm left with g equals 4 times 3, which is 12. Okay, my last two examples for this level of the standard. Doing great so far. We have 7 equals negative p divided by 5. So, to get this p by itself, I need to get rid of this 5 and this negative sign. So I'm going to multiply by negative 5 on both sides. So, negative 5 and negative 5 cancel here. Okay, I'll put a little dash through that too. I'm left with p on this side equals negative 5 times 7, which happens to be negative 35. And on this side, 1 equals negative 1 over 8 times x. I will multiply by negative 8 on both sides. So negative 8's cancel, and I'm left with x on this side equals negative 8 times 1, which is negative 8. Okay, so that concludes level 1. On to level 2. So for level 2, not too much different from level 1. So you will be able to solve equations using two different operations. So level 1 of the standard, we only needed one operation. For this level of the standard, we need to use two. So let's take a look at a couple examples. Scroll down a little bit. Okay, so we're still going to solve for the variable. So that's our main goal. So as we said earlier in the video, our main goal for level 1 was to isolate our variable to get a solution. So same thing for this level. We have the same goal. Isolate the variable. I put that in all capital letters because that is extremely important. If we're not isolating our variable, we're probably not doing it right. Okay, so let's take a look at this example right here. So I'm going to put my pen over this 2 right here. If that 2 were not there, we would have negative 8 times m equals 50. So we know by the division property of equality, we could divide both sides by negative 8 and m would be by itself. So we know how to do that. But we have this 2 here. This 2 is being added to our expression that has the variable. So how do I get rid of that 2? Since it is being added, we will subtract 2 on both sides. Okay, so 2 minus 2 is 0, so I'm left with negative 8m equals 50 minus 2, which is 48. Okay, so now if we look at this, we have a one variable equation with one operation, and we just learned how to solve those. So I'll make another t. I'll divide by negative 8 on both sides. Okay, negative 8 divided by negative 8 is 1. So I'm left with m equals 48 divided by negative 8, which is negative 6. Great. So all we did here, we took a level 2 problem with 2 operations, broke it down into a level 1 problem, and solved our level 1 problem. Okay, let's move right over here. So I'll make my t. So I have 9p minus 9 equals 18. Same thing. This expression right here has my variable. So I want to get this expression by itself. So it would be by itself if it were not being subtracted by this 9 right here. So since this 9 is being subtracted, I'm going to add 9 to both sides. And of course, if this isn't making sense right away, please come see me during class. So on this side we have negative 9 plus 9. That is 0, so I'm left with 9p on this side. Put my equal sign. 18 plus 9, which is 27. So I have a one-step problem now. Make my t. Want to divide by 9 on both sides. So 9 divided by 9 is 1. 27 divided by 9 is 3. So I have 3 equals my p. Okay, moving on. Alright, 4 more. So, this problem right here, we have an expression with our variable being divided by this 7. So if I put my pen over the 7 and I had r minus 2 equals 2, well, that's a one-step problem. So we know how to solve that. So our issue right now is this 7. So since this is a fraction, I'm going to multiply by 7 on both sides. So these 7's will cancel, so I'm left with r minus 2 equals 2 times 7, which is 14. Okay, make my t-chart. So my 2 is being subtracted from my variable, so I need to add it to both sides. Negative 2 plus 2, well, that's 0. So I'm left with an r equals 14 plus 2, which is 16. Okay. And of course, we could check all these answers too if we were really unsure. So this one, for example, I said r equals 16, so I could plug 16 in for r up here. So I'd have 16 minus 2, well, we know that's 14. 14 divided by 7, that equals 2. So our equation is true, so that means this solution is correct. Okay. So let's go over to this one. I need to get that 10r by itself, of course. So this 3 is being added, so I'm going to subtract 3 from both sides. So 3 minus 3, that cancels. I have a 10r equals negative 87 minus 3 is negative 90. So one more t, divide by 10, since that's being multiplied to my r. Divide by 10, 10 divided by 10 cancels. So I'm left with r equals negative 90 divided by 10, which is negative 9. Great. So this example right here. Start off by making my t-chart. I know this expression that has my variable needs to be by itself. So my issue is this negative 7. So since I have negative 7, I'm going to add 7 to both sides. So if I do that, negative 7 plus 7 is 0, so they cancel. I'm left with n divided by 3 equals negative 12 plus 7, which equals negative 5. Okay, so I have a fraction here, or my variable is being divided by a whole number, either or. So I need to multiply by 3 to get that n by itself on both sides. So those 3's cancel. I'm left with n equals negative 5 times 3, which is negative 15. Great. One last problem here. So I have negative 4 equals x divided by 2 plus 1. So let's make the t. Okay. So a tendency is actually to bring this 4 over onto this side, or this negative 4 over onto this side. But if we do that, we are bringing numbers over to the side that has our variable. And we don't want to do that. We want to do the exact opposite. So instead of adding 4 over, I'm going to subtract this 1 from both sides. Okay. So 1 minus 1, that cancels. So on this side I have x divided by 2 equals negative 4 minus 1, which is negative 5. Okay. So to get this x by itself, that 2 is being divided. Okay, I'll multiply by 2 on both sides. Okay, so these 2's cancel. Left with x equals 2 times negative 5, which happens to be negative 10.